Hello, everyone. This is chapter 2, frequency distribution. And this video will be just the basic video or a lecture on how frequency distribution tables are made. What does it mean for, what can you infer from the frequency distribution table? What does it mean to have a frequency polygon, cumulative frequency polygon, histogram, etc. Basically, a review of some of the descriptive statistics dealing with making tables, as well as some inferential statistics from a frequency distribution itself. So some of the stuff that we are going to review over the course of this lecture, make a frequency table for a set of data. So basically, this goes back to an interesting point about frequency or any kind of statistical data as such. You kind of make it tabular. Okay, this is something which we covered probably in basic statistics a little bit, but not so much elaborately. Chapter 2 probably will be your first introduction to make a table and analyze data from that table itself. We will again just show you very briefly organization of data into bar charts and pie charts. In fact, I will just scan as I have those in the lecture slides, but I'm not going into the details because we have seen the details of doing bar charts and pie charts as fundamentals of Excel in the previous chapter. We create a frequency distribution, understand what is a relative frequency distribution, or relative frequencies versus what is known as cumulative frequency, and then plot a frequency polygon and a cumulative frequency polygon. And also, very importantly, in this chapter, we will be plotting histograms. So just starting off, this is just kind of a wider example of some of the tabulated data you may find. This data set, by the way, is uploaded in your datasets folder on Blackboard. It's kind of a dealership selling a lot of cars in different locations and what kind of vehicle types and what is the profit range given the age of the vehicle. So kind of different cars and location, but how to plot some charts in bar graphs. That should be the first steps you should have in any descriptive statistics sort of organization. And this is what we went over in chapter 1. You do a bar graph or you do a pie chart kind of thing, number of cars sold and the percentage of sales based on the type of car. We did show you a pie chart in the last chapter itself. We reviewed this as basic things to know. These are descriptive statistics. But what would be interesting is if you can group and classify the data according to a group. So that's what frequencies are all for. So frequency distribution kind of encompasses the whole idea. The bar charts and the pie charts are very visual ways of representing your summary data. And no offense with that, they have all sorts of percentages of each kind of classification. But if you think about a frequency distribution table, it goes much beyond that. As I said, you can also do some inferential kind of statistics here. Class interval, you put up an interval on the basis of the profit numbers that was given to you right at the start here. And we are going to know how to do these. There are certain rules we would follow. Class intervals. There you have a lower limit and upper limit for the class interval. The frequencies are one of the most important components of a frequency distribution table, of course, and they represent the number of items or the number of stuff that goes into that class interval. So number of vehicles whose profit level is between these thousands of dollars. So that's 8. Between this class interval 11. So these are the frequencies, and this is slightly tedious because you have to count out the frequencies when your class distribution table is given. We also want to feature one more thing here, which is the midpoint, 200 to 600, 600 to 1000. Midpoint is just the midpoint amongst these class intervals. So if it's 200 to 600, the class interval midpoint is given by 600 plus 200 divided by 2, 800 divided by 2, 400, 600 plus 1000 divided by 2, 800, So since the class interval is 400 every time, you can just add 400 here without computing the midpoint every time, because this is just a monotonic function. And creation of a frequency distribution table. So all this is good. The data is given to us. But first, looking at the data, how do we come up with a table? We need to know how many classes we can make from there. So we just cannot say randomly that this is the profit level of the car sold in the dealership given for all locations. Now, classify these profit levels into cars sold. That's very random. We need to know how many classes we are supposed to make and what is that interval or the width of the class. Okay, so the first two fundamental things are building up the frequency distribution. There is a well-known formula we use for the number of classes. This is called, ladies and gentlemen, the 2K rule. Two K rule of determination of the number of classes. Okay, where K equals the number of classes. Let N equals number of observations. So what does the 2K rule say? The 2K rule says you compare that 2K to the power K, compare it to the number of observations. This rule must be satisfied. So for instance, let's suppose we have 110 observations, a number of data points. Observations are nothing but data points given to us. The 2K rule would be like this. So 2 to the power 2 would be 4. 2 to the power 3 would be 8. 2 to the power 4, 8 times 2, 16. 2 to the power 5 will be 16 times 2, 32. 2 to the power 6, 32 times 2, 64. 2 to the power 7, 64 times 2, 128. And possibly we can stop here. I will show you 2 to the power 8. 2 to the power 9. We may not need 9 classes, thankfully. The 256 times 2, that's 512, I guess. So I stop here. We can pick out 7 classes here. Why? Because that's the rule we are following here. K is the number of classes, ladies and gentlemen. We have 110 observations. N equals 110. So 2 to the power K should ideally be greater than N. Sometimes if it's equal, you can still take that many classes. So if you can take, if number of observations is 16 or 32, you can take 4 or 5 classes. But it's always great, better or safe to err on the side of more. So if 2 to the power K is greater than 10, and 2 to the power 6 is 64, less than 110, but 2 to the power 7 is 128, since 2 to the power 7 equals 128 greater than N, we will, that's 110, we will consider 7 classes. I'm just kind of throwing out any 110 observations given to you, and we are just at the starting point of understanding how many classes we will have. Now, I just mentioned that to err on the side of more is better, but sometimes do not do redundant classes. If you feel that 4 classes are sufficient for 16 observations, go ahead with 4 classes. Don't jump into the 5th class, where you will probably end up with having no frequencies at all. And more on these as we build in frequency tables. Okay, so that's the 2K rule, number of classes. So the next thing, after the number of classes, we can safely go to the other thing, which is the class interval of it. We now know the class number of classes if we just know the numerator here, which is the maximum value in your data set minus the minimum value, the highest minus the lowest observed value divided by the number of classes. So we use the profit level data set. We see the highest level of profit was these, the lowest level of profit divided by the 8 number of classes. Let's see why we took 8. What was the number of observations here? I really don't know what the number of observations is, but I do have a data set on this one. So there is a way to know number of observation points or number of observations, but I see they have taken 8 classes. So you take the highest value minus the lowest value divided by 8. If it's a decimal, please round up the number, the class weight. Do not put it as 374. For example, I would consider these as 375, or better still, round it up to a multiple of 10 or 100. It's 400 is a good class interval. So 200 up to 600, 600 up to 1000. Anything rounded up to 10 always makes for a good visual as well as numerically effective measure. What are tallies? There is a way in frequency distribution. You do like this. I'll show you an example of a tally. So you have the number of classes or class interval. Actually, you already know the number of classes. You can derive the class interval. That's the first thing. Frequency. Before you move to frequency, and now we are gradually building up the table, then you find out the frequency. There is a way. We say 1, 2, 3, 4, 5. So then we put a cross check in here. You can make these straight and make them slanted a little bit. Something like a cross check on this whole thing. Okay, after you do 5. And then there are 5 observations within that class interval, 5. So we say 5. And then if you have 2 more, you just put 1, 2. So you have 5 plus 2. When you do 5, you just do a cross check kind of like this. Okay, 1, 2, 3, 4, 5, and then you check it out, and then you do the others. So this is slightly tedious. You have to find out within each class interval how many observations fall. Okay. Now, what other aspects? We have done the frequency tally, and the frequency is done. So that's 8, as you can see. 5, 6, 7, 8, 5, 10, 11. So that's how you can, or you may or may not insert the tallies. I don't encourage students, but if they want to, they're more than welcome to put the tallies. Otherwise, you can. Tally is a good way of actually cutting out observations as you are looking at a big data set. Usually, I will give you 50 to 22 observations at the most in an exam. But if you want to use a larger data set in a project, be careful. A tally is always a good way of correcting your sum. Otherwise, if you are very strong, you can just do your own calculation of the frequencies in each interval. 1 or 2 things about this frequency. And I will show you relative frequency and cumulative frequency in a bit. When you put in the class intervals 200 until 600, 600 until 1000, you put all 599 in here. If there is observation on 599, you count it here, but if it's 600 and above, count it in the second class intervals. So this is strictly 200 until 600. So anything above and beyond, at or beyond 600 should count in here. Anything at or beyond 1000 should go to the next class interval. Now, what is relative frequency? For these, I will show you. Actually, I can show you the lecture slides itself, not a big deal. Relative frequency is you take the sum of the total frequencies that you get should match the number of observations you have in the data set. And for each frequency, 8, you divide it by the total. 8 divided by 180, 8 11 divided by 180. These are basic things you can do very easily in Excel. And in the Excel video, you will see I show these as with Excel formula, and it's very easy to do. I might want to show you a few things today too in this video. So that's relative frequency. And then there is cumulative frequency. Cumulative frequencies are just added up things, 8 plus 11, 11 plus 23. How much cumulatively it is getting up as you cross one interval to another. One application of this cumulative frequency, apart from just knowing the frequencies of the relative values in each class interval, you can answer major questions like how many cars are sold with profit levels less than 1800. So we will say it's 80 cars just by looking at the cumulative frequencies. We didn't have to do anything else. And the cumulative frequency polygon, which is a very nice graph for doing this, can also show you the same. Again, Excel will be the best handler of these processes, doing these graphs. For the normal frequencies, though, you have a graph called frequency polygon, okay? A frequency polygon, this initial picture of a cumulative frequency and frequency polygon, you usually put the midpoints or just the class intervals here and plot the frequencies. It's an easier deal than cumulative frequencies, because cumulative frequencies, you are getting one more column, okay? Before I go to histogram, let me show you some of the pros and cons of cumulative frequency. The graph itself, and I will illustrate a problem with this, by the way. The graph itself, it's very easy to do. Once you can do it, you use the insert function in Excel, or you can plot yourself if you want to. But some of the things is, one of the disadvantages would be, you should check with the table as well as the graph. Sometimes a question will ask you infer from the graph, but it's always to have a neat table to make sure that your graph, the way you are looking at the graph, is tallies with the table. So any vehicle less than 180, 1800, I would pick out 1800, less than 800, 1800, around 80 of these vehicles, but visually see, it was not so easy, okay? There was a pointer here, but you have to make out within 1800, 80 vehicles were sold. So you kind of probably have to go back to the table, but this still remains a nice visual way of representing how many fall within that range or within that interval. Then there is another thing we do, which is called a histogram. This specifically, we need the use of Excel. But for histogram, we probably need a full data set, and I'll show you in that thing in Excel. But a histogram has some differences with the frequency point. Histogram is, by the way, the most accepted, most benchmark way of putting all your data representation in a graph when you're doing frequency distribution. Very good way. If you just put your histogram in your assignment question or in your project, that makes me happy. That's the way your report should look like. You have a histogram. You plot the cumulative frequency polygon as well as the basic frequency polygon. You capture much of the same results, but a histogram is much richer. It's a rectangle, it's like a bar graph. It's showing every class interval in a much more proper way. Frequency polygon sometimes just looks at the midpoints here. And then you can also infer, you can superimpose a cumulative frequency polygon over a histogram. So histogram has all levels of looking at the data. The advantage of the frequency polygon, you can put two in a row, but over time, this advantage has been blurred to an extent and to which histograms have been used in practice to represent frequency. So that's where I end with my lecture here on frequency distribution. Go over these carefully because my next set is on deriving all these things through doing an actual frequency distribution and building up from there. I'll stop these. So some problems, some actual problems may or may not be in Excel. So These problems, ladies and gentlemen, are on your blackboard as a problem set 1 or 2, sorry, in module 2. But let's just go over them in details, make sure we understand. So I'll go over number B, which is already, the answer is given. Data consists of 45 observations, 0 and 29. What size would you recommend for the class interval? Size just means the width. Okay. So n equals 45. First, we need to know the number of classes before we can we infer about the width. So n equals 45. So what is the number of classes? Using the 2k rule, 2 to the power 6 is 64, which is greater than 45. So we will take 6 classes for this data. The class size or width is upper level of the class distribution, known as the lower level of the class distribution, divided by the number of classes. That's 4.99. I will easily round it up to 5. You can put 10, but I think 5 is okay for the class. Data consists of 38 observations. How many classes would you recommend? Oops. 2k rule. 38 observations. We know 2 to the power 5 equals 32. That's, oops, what's going on? 2 to the power 5 equals 32. 32 is less than 38, So let's move over. 2 to the power 6 equals 64, greater than 38. So select 6. Okay. Data consists of 250 observations between 235 and 567. What class interval would you recommend? So again, 250 observations. Oh, that's an odd. So 2 to the power 7 equals 2 to the power 6 is 64. 7, 128. 2 to the power 8 equals 256. Well, since 256 greater than 250, choose 8 classes. And what class interval would you recommend? So what is the difference between the upper and the lower class size? It has a lot of name: class size, class width, class interval. Oops, 567 minus 235. So I'll just quickly use my calculator here. That's what you're supposed to do probably. 567 minus 235 divided by 8. 537 minus 235 divided by 8. 41.5. Then you can round it up to 42, but for me, I would say 45 is a good rounded number. I mean, I won't be too upset if you take 50, but do not take 41.5. That class interval is just messed up. You will, it's probably right, but it's not the most efficient. It's not a good visual effect of the frequency distribution. And when students do that, I'm thinking, well, rounding up is a better thing. The same thing here, as you can see, minimum value 42, class interval of class width is 15. So what it was, in this case, the data is to be organized into a frequency distribution table. Data consists of 53 observations, minimum and maximum is given. So you have 6 classes, since 2 to the power 6 equals 64 greater than 53. And if you find out the class width, it's 15. Minimum value is 42, the lower limit of the first class. Let's not take these as 42. This is another thing. Realistically, if your lowest value is that, do not start that as the class interval. Start with something rounded up. If your lowest value is 40, 40 is a good lower limit. So lower limit means lower limit refers to the minimum value of the first class interval. So that's your lower limit. Start with like this: 40 to 55, 55 to 70, 70 to 85. Remember, the class width was 15 according to our formula and everything. 85 to 100, 100 to 115, 115 to 130. I've taken 6 classes width of 15. We don't know what the frequency is. Whereas the data set, we have no way to complete this part. Now, the next one is important. Now, what I'm going to do is I'm going to do this problem and take it back to Excel to plot some graphs based on this problem. Question 2 is showing the home prices for houses sold in Warren, Pennsylvania last year. What is the class interval? Very easy questions out here. The class interval, as we can all see, 120 to 150, 30 is the class interval. How many homes were sold last year? All you have to do is the frequency is given to you. You can just add up in Excel. You can use the sum function to do that very easily, or if you want to do it manually, you just use your calculator. How many homes were sold last year? I found that in Excel. Show you in a bit. 105. How many homes were sold which were less than 210? We can see lots of homes, but for that, we need to plot a cumulative frequency distribution table. So let's make this a full frequency distribution table. We can answer this question, I think. What is the maximum and minimum selling prices? The maximum is 330, minimum is 120. And what about the other graphs? Let's take this problem to an Excel example. And I do have the Excel spreadsheet where I copied the problem from the scratch. And this is the one that we are doing right now, ladies and gentlemen. Selling price is given. See, I use the sum function in Excel. And I'll give you lots of doses of Excel. The next video on frequency distribution in Excel. 105. Midpoint, I said it's a very easy way. 120 plus 150 divided by 2. 135. But from that, it is just an addition of 30. So why? Because the class interval is 30. So 165. I'm just writing these out. 195. 215. Sorry, 225. 255. 285. 315. Okay. Now, relative frequency. I always encourage students to use Excel as much as possible. In fact, in your homework for this chapter, I've encouraged you to put the Excel outputs. In fact, that's mandatory. So try to learn how to do it most efficiently in Excel without using calculators. The actual frequency divided by the total number of observations. If you want to do it most effectively in Excel, please put a $sign here in front of the letter and in front of the number for sure, or you can use the F4 function. And if you just click or drag, it will give you the relative frequency. You see, you don't have to go tediously using your calculator. Use Excel function. The only trick is put the $symbol. The $sign controls that number. That means every time that number is controlled, that's the one that is being divided with. Cumulative frequency. A little trick here, ladies and gentlemen. Here you start with 4, right? Always put the cell number as your value. And then you put 480. It's 4. In the next one, put this plus 30. Okay. If you continue like these, the click and drag, should give you the whole cumulative frequency. Why this is important to know? Again, manual thing. You just cannot go on computing, especially if you have a large distribution to do. In practical life, you may have to do much larger distribution than you face in assignments or exams in your course. So what all I did, I put 18 plus this, always do on the last column of cumulative frequency. And then in the next one, what I did was I put this one, not from here, plus 30. So when Excel understands that you're adding them, somehow it realizes you're accumulating them at each point. So that's how 105 comes up. This is like a full frequency distribution table. It's very interesting. You may or may not put in the midpoint, but I want you to show these numbers, this cumulative frequency, frequency, relative frequency for sure. These 4 columns, the class interval, selling price. Let's make these class interval, put these as selling price. Instead, because the frequency distribution table really looks nice if you put class interval, frequency, midpoint, relative frequency, cumulative frequency. Okay. Now, doing all those graphs in Excel, frequency polygon. So, for example, frequency polygon is the easy one. You build up the class interval, and then either you can take the class intervals or the midpoints on your horizontal axis. I do not care. Frequency was given to you. Many people are just too strict about having the midpoints, excuse me, for frequency polygon. So let's do these midpoints and frequency. Insert function, just a line graph. Obviously, Excel will sometimes mess up. Complete mess here. Let's see what data it has selected. It has not selected the right data. Let's just choose the midpoints on the horizontal axis. Okay. And take off these midpoints, which is already highlighted, remove these, and the frequencies on the vertical axis. There you go. Sometimes Excel messes up. All you have to do is just right click, select data, and kind of figure out what is the horizontal axis and what is the vertical axis, the legend entries. I can do the same one, putting the class intervals and the frequencies, and that would be the same frequency polygon, in my opinion. I would rather try to take these out. Any blank space sometimes makes Excel mad. I have experience. So see how it nicely comes up this time because there was no blank space. I guess that was the problem in the first one. It couldn't understand what the blank space is doing. You have to remember Excel is like a software. So that's a frequency polygon of our data. It's also a frequency polygon. Now, cumulative frequency. In cumulative frequencies, ladies and gentlemen, because it does cumulatively, we have to think about the upper limits under which the cumulative frequencies are stacked. So the upper limit of each class interval, 150. You just have to, this is a bit tedious, but it might not take you a lot of time. You just put the upper limits, enter them manually if you can, 240, 270, because we are really trying to find out what lies within the upper limit, 300, 330. And just copy and paste these. Now, since we used a formula over there, don't do just regular paste, but paste special values. This one, okay? Always do paste special. Whenever you're doing something special. Here I copied the formula, something special. If I transpose the numbers, paste special, okay? Cumulative frequency. Again, I don't want any controversies with Excel. So I will just put these two. In a simple graph, line graph. But still messed up. Anyways, it will not. Right click, select data, edit. The horizontal axis should have the beans. That's what Excel always messes up. The vertical axis should not have the beans, so cross that out, remove it. It should have the cumulative frequency, and there you go. It's a good thing in Excel graphs, do not have redundancy, take these off. Instead, write what this is here on the horizontal and the vertical axis. I would say I would want to put an axis chart element. So click on these, add chart element, axis titles, horizontal axis. What do you have here? The selling prices. That's the basis of our frequency distribution table and the graphs. And on the horizontal axis, you have, on the vertical axis, excuse me, you have home sold. But cumulatively out here, the same thing you can do in these graphs too. You can just make these look beautiful. This is very important for your projects, for reporting purposes. It looks very neat, as if you're submitting a report to me. That's your cumulative frequency. I do not want to do a histogram right now, particularly because a histogram won't be possible without some of these data given to us. You can do a bar graph, which is kind of like a histogram, but not the Excel histogram. This is a problem from your 9th edition of the textbook. It would be page number 22, page 43, number 22. It is about the lead times when order is fulfilled. So if you give a lead time and order, that's a frequency, complete frequency distribution, by the way. I could put Times New Roman. So that makes it a little bigger for us to see. And let's just make all of these centered. So that's the frequency, relative frequency, the same formula, remember. It's this actual frequency divided by this, by the total frequency, but do not forget the dollar symbol. Somehow my F4 function is not working here. So I am just putting a dollar sign in front of the letter and number. This is your relative frequency and cumulative frequency. Remember the trick. This one equals this one plus 7. Do the third one, and then it will take up by itself. It's 12. 1 or 2 is big enough. And then you get these numbers. So that's like your frequency distribution table completed. Now we want to see how we can answer these questions based on a cumulative frequency graph. And this is all our relationships for the graph or the information needed, beans, days, and orders fulfilled given the lead time in days. So this is the class interval, and this is the cumulative frequencies, how many orders have been filled. So let's draw a frequency polygon or graph to be more precise. Again, graph looks a little messed up, but right click, select data, edit. These are the beans on the horizontal axis. Take out the beans from the legend entries. This is your cumulative frequency. Take these off. Okay, so there you go. How many orders were filled in less than 10 days? You can answer these on the basis of the table. I already told you that look at the beans and the table, look at the graph and the table. So below 10, it's 13 orders. Let's see if that is possible here. Below 10, we should not cross 15, so approximately 13 orders. So that's a good way of illustrating what we just learned and putting the frequency polygon and the cumulative frequency polygon, answering these. Plot a cumulative frequency polygon that was one of the questions in that problem. So we have already plotted, and based on that, another question, 60% of the orders were filled in how many days? So 60% of the orders, what is 60% of the orders? 60% of orders would be how many orders? Equals how many total orders were there? 40. 60% of 40. So that brings us to 24 orders. So 24 orders are filled in less than how many days? We will say approximately less than 14 days, because as you can see, if it goes to less than 15 days, it might be 25 orders. So 24 orders. And you can always take the help of the table, as I did right now, less than 14 days. You can write 15 days. I won't take off your points. It's always an approximation that the best, the precise estimate is the best, right? More precision, the better. Okay. So that kind of another, it's kind of another problem that you can do with frequency distributions, answering these questions. That concludes my first video here. In the second Excel problem-based video, it's just problems, and I will show you some more applications of these kind of problems, and what the questions being asked like these based on frequency polygon, cumulative frequency polygon, and most importantly, histogram. So please check out the Excel-based video.